Okay, so I'm going to talk to you this morning about Lattice. So it's an internal micro front end framework that we're using here at Netflix. I am Michael Possumato, part of the Revenue and Growth Tools team at Netflix, and we're a little bit of a smaller team, so we have the luxury of trying some of these cool new things and see how well they work. Also, we kind of are doing our own dog fooding approach to see, hey, is it worth kind of investing in this sort of implementation moving forward. So, a little bit of the agenda as far as what I'm going to be talking to you about. So, I'm going to be talking about the front end stack at Netflix. It's pretty common and it's shared across organizations. I'm going to talk about what our approach for a micro front end looks like, what we developed with Lattice, as well as what's going on under the covers. So inside of it, some basic code samples. They're somewhat pseudo-codey, but it's enough where you can kind of follow along with the approach. Also, some of the future aspects where we're hoping to go with this sort of framework, and just open it up to general Q&A. So the front end stack at Netflix is technically becoming more consolidated and streamlined. We're seeing a lot more heavy use of React. For instance, there was some usage of Angular, but those apps are now kind of dwindling away, and we have heavily adopted React. So our design system is Hawkins. There's a blog post about it in the Netflix tech blog, and it has a whole bunch of boilerplate components that we can leverage in our tooling and be able to kind of share some of this functionality. The other thing we're noticing is as our tools and applications get larger, the traditional JavaScript project is really difficult to maintain. So we're seeing a lot of adoption of TypeScript, which is good for us. It's nice to have those rigid interfaces defined. In this way, when we're doing any sort of refactor effort, it's pretty clear when there's going to be some changes that could cause problems. Finally, Webpack is our bundler of choice. It's a little bit complex to understand. I would say some of our apps, or the majority of our apps, kind of leverage Create React app under the covers. So a lot of that config is essentially boilerplate. But one of the things we wanted to lean in on is, well, since we're using a Webpack bundler, is there any functionality that we can get from there to potentially lead us down this module federation or these front end modules? So Webpack has been hugely beneficial. Where the future goes, I'm not sure, but there will always be some sort of legacy browser support, and you'll need to transpile your code. So I don't necessarily see the Webpack area going away anytime soon. So, what's the common approach to tools? And it's basically front ends everywhere. They're all duplicating the same sort of boilerplate or functionality. So there's an application code base which is talking to at least one service, so one backend for front end, maybe reaching out to services, somewhere else, and potentially these backend services get shared across different front ends. So that can happen a lot here at Netflix. One of the things that we see is they all provide a singular purpose. So these front ends are developed in silos. They have their own development life cycle associated with it. And that's just basically a CI CD process, some sort of deployment to some hosted cloud. And then they're all in their own walled off garden. And that's it. They don't necessarily talk to each other. They may share component libraries, which is super common in the React world. But when it comes to something like sharing an organism or functionality specific that front end application provides, it's just living on its own. And that was the one area where we saw some consolidation because we noticed that there is this whole side of the equation that's redundant. So, for instance, application routing, Apollo client, all of this boilerplate code where we're not really focusing on the logic that the front end provides. And the idea is, well, how do we kind of consolidate that? And then it's, well, what if instead of developing these thick clients, these front ends, they can essentially still live on as their own client front ends, but they could also expose modules through the web. So, what if we took the little cloud icon? So, we have the internet here or intranet, and it's going to deliver parts of the application specific that it would like to expose for others to consume. And that's where we start getting down the path of micro front ends. So our approach to micro front end in the tooling team is similar to that of how Netflix does microservices. So I'm sure some of you are familiar with the large web of microservices here at Netflix, and we're thinking, well, couldn't we do a similar approach with front ends? So we wanted to take a couple of core competencies or principles in place in order to allow others to rapidly adopt this sort of approach that we wanted to take. So a couple of the bullet points here are we wanted this to be a low friction adoption, which means that, if everyone's using React, well, let's lean in on that. So what can we build for Lattice that would help others that are building apps in React easily able to consume remote modules or to be able to publish their own? And then we would have the teams kind of own that individual front end component or that published component, I'd say. I use the term component loosely because it's really a full-fledged part of the application. This is going to consist of multiple components, multiple services, but it's owned by that individual team. The other thing we wanted to do was, well, how do we have a weak dependency model? Meaning, we can obviously do this today. This is nothing new when it comes to having a package JSON, referencing a module, and then just having that shared library published somewhere else. Well, that's a highly coupled approach. So, what can we do differently? So, we started researching options to fetch modules over HTTPS. There's a lot of kind of cool things out there that are somewhat in the future where we think about something like Dino or something like native modules that can be supported in the browser. But we were not quite there yet. So we kind of looked at some options. We are leaning on the Webpack federated module front, which I will talk about later. How do we kind of make the approach highly aligned but loosely coupled is a common phrase here at Netflix. And one of the ways we can do that is with TypeScript. So TypeScript is really just like a type enforcement, but it's not going to do anything at runtime. So it's purely just when you're developing your application or your front end plugin. So you would be able to understand, well, what does the interface look like? What am I going to be expecting? So you can have these TypeScript declarations and I refer to it as like a definitely typed project, essentially for all of the plugins or all of the host applications where you're aware of the functionality that they provide or you can kind of enhance. The other thing we were looking at is, well, how do we drive this configuration through metadata? This was kind of extremely important because the approach to our tooling is becoming more generic, and we want singular tools that can provide multiple use cases or address multiple use cases. The only thing is, it's very difficult to do that. There's always going to be some customization or some conflict in requirements. However, if we had a metadata model in which tools or front ends can reach out externally to other plugins to fulfill that need, well, now we're starting to kind of decouple, but we still provide that core functionality. So these services essentially can map their components by keys. This is also essentially what the federated module plugin does with the exposes property, for those of you that are familiar with it. We take a similar approach, but it happens in our glue layer, which I'll talk about. And then finally, we want to encourage rapid development. And essentially, to do that, well, we want to remove those dependencies. So that's where also fetching over HTTP or fetching over the web certainly helps. So, what is Lattice? It's a tiny framework. It's declarative and it's used for extending and customizing React applications. It's pure abstraction of components and essentially the view as far as where they should belong. And we are essentially modeling, say, props with TypeScript interfaces or those declarations that I was talking about, which can encourage that decentralization. So we're providing those design patterns that applications can follow. So they would essentially declare a host, what services they can provide, and as well as those interfaces. And out of the box support is crucial so that application developers can leverage plugins or become a host without having to understand Webpack or federated modules. So there are some convenience functions that we're building within the Lattice framework that either hosts or plugins can use, tie into their Webpack configuration, and they don't necessarily have to worry about things such as eager consumption, singletons, and any of those sort of underlying configurations. So we have this bare bones out of the box support. So inside Lattice, what does it look like? So it's super simple. Areas in the dark pink are what we exposed. So those are the only areas that we expect applications to consume. So that would be these plugin modules, which we don't actually build or provide, but we provide an interface for developing a plugin. And I'll talk about what that interface looks like later. We also have in the center section, we have asynchronous loaders. So we've developed essentially the Webpack federated module loader, and we've looked into some other loaders which we can do also. However, we're leaning in on the Webpack route, but the way it's architected, it's all abstracted out, or we can add another one. And the way we do that is essentially by URIs. So there's a prefix or a host, and we use that to distinguish which loader to use. And then finally, the plugin host. So every host application needs to define this. And all it is really is React context. But essentially, by defining that host, you're going to define everything required in order to reach out, grab the plugins, any sort of context that should be shared, such as maybe global state. And you're also going to provide, if there's an API for some sort of bi directional communication, that would all get defined within this plugin host. And finally, it's all built on React. So there's nothing uh, outside of it that we're looking to support. We're purely React based. So when I talk about a host application, these are always React based applications. And again, with the Netflix ecosystem, they're written in TypeScript and they're leveraging Webpack. The way this kind of sets itself up is the areas in yellow is everything that the Lattice framework provides. So the host application, again, it would just bootstrap one of these plugin hosts, which means it would just have to contain it within its tree somewhere in the React lifecycle. You're going to most likely put this at the top and you're going to set some information. So you're going to set the context, you're going to set some config, and that last line is called loaders, and that's for if you wanted to extend the functionality. Again, so we've abstracted all that out, but it's possible a host application maybe wants to implement a global loader or vanilla JS loader where it would almost act as a tag manager where maybe you're injecting a script. So you certainly have the functionality to essentially tell Lattice, hey, I want to control how this particular module gets loaded. It's optional, doesn't have to be done. When the plugin host has all of its information, it's essentially going to reach out to all of those loaders. It's going to essentially fetch all of these modules over HTTPS, and it's going to store them within context. It's all asynchronously loaded, promise based, lazy based. And essentially, once it's ready, then it will be able to kind of provide that information to any sort of pluggable components that wanted to leverage it. So that moves into, well, what's the scaffolding look like for setting up one of these plugin hosts? So again, this is a little bit of pseudocode, so it's not necessarily 100% perfect. We wouldn't expect somebody to implement it this way, but it does show essentially what is required in order to make this happen in a host application. So the first step is to go ahead and fetch that configuration metadata. So this is probably very important because we don't want it to exist within the application. We don't, we want to have those weak dependencies. And as soon as we hard code, say, well, a URL to a plugin, that's not going to scale. We'll have to make code changes. So the idea here is this metadata needs to be sourced from an external service. So this is just a mock hook call that would essentially source that configuration data. And I'll show an example of what that would look like, very simple, in one of the following slides. Once we have that configuration data, you would essentially pass it to the plugin host. And this would have all the information for the app context. So we kind of shard our applications so you know what you're working with. So that context is very important. So it's possible a plugin will be shared between multiple applications, and the plugin can decide what it should render based on that context. We also will have information in this config, such as those external services And once the host has this information, it'll go ahead and load those remote modules. Once those modules are loaded, you can then start leveraging them. So we have this two approaches. One is for hooks or state managed, and another is for the render layer, which I'll show later. So there's three arguments here. One is an identifier. So these are essentially magic strings. In the proper world, these would exist as essentially TypeScript exports. So these would be constants, and they would be shared between this host application and the plugin. So instead of having this as a hard coded app routes, I might have something as like host application dot application routing, and then that sort of key can be used in plugins as well. The second argument is for extra state that maybe you need to provide. Generally, it's not required. And the final one is for the initial state. So these are just the default routes. Basically, what I'm doing here is I'm allowing any plugin to extend this route or this router that exists in the host application. And we'll have our own routes, and then we'll also run it through the Lattice pipeline so any other plugin can go ahead and add its own routes. Finally, you'll have a router instance. This could be anything, say React router, and we're going to pass in that information that we got. And that's going to consist of our default routes as well as anything else that was extended through a plugin. Finally, how does the UI become kind of more fluid? And that's where we have these pluggable components. And it uses the same principle as state. There's these unique identifiers which should be shared. They should come from a TypeScript declaration somewhere. And we would basically now be rendering that area of the page, but we would also extend the children with anything or any plugin that responded to this identifier. And obviously, the children that we supply here are the default elements. And plugins can decide to add to this content area. They can completely remove the information that's showing. So they have a lot of control, maybe too much control. However, at Netflix, there's a concept of freedom and responsibility. So we can kind of take for granted that, well, plugin owners should obviously do due diligence and make sure they're implemented properly. So what does a plugin look like? This is pure boilerplate. There's absolutely nothing in here that is specific to Lattice. So for instance, you're going to have an application. It's going to be written in React. We're kind of going with that standard, what we see here at Netflix. And you're going to have components. And then you're going to have the intention of sharing some of those components to the outside world. And the way you do that is with this pink box, this plugin module. And it's not a Lattice specific declaration. It's basically you would have to abide by the interface to go ahead and retrieve the components. And I'll talk about what that looks like later. And then that sort of function method would get exposed through a federated module bundle, which is going to use just Webpack federated module and then publish that to the web. So this is an example of a very crude plugin. It's essentially vanilla JS, but one of the things we would do is we would define what components we want to basically expose. So I have two here. I have a header and a menu, and I've kind of created a basic map, whereas those keys are the identifiers. So again, these would come from a TypeScript declaration, but I'm keeping it simple. So then when Lattice expects this method to exist, this get component method, and it's going to pass in all of the information it has, which are those arguments. And the plugin would go ahead and would say, it's like, okay, I received an identifier. Do I have a matching component that I actually want to render into the page? And if it does, it will go ahead and it will return a fragment that consists of its own custom component, as well as the children that were passed in from the Lattice host. When it comes to the configuration again, so this is what maybe a host might look like or what service configuration might look like where I was mocking out that hook. And there's a basic kind of application context, and then there is configuration that goes across, and it will talk about how to go ahead and fetch this module. So this talks about, again, with those URI syntax. So the path, that Webpack 5 is going to correlate to a Lattice loader. So we will know that, oh, okay, we're supposed to use that Webpack 5 loader in order to fetch whatever the remaining part of the path is. And in this case, it's just a bogus URL to a JS file. The options is essentially correlated to the loader. So in this case, this is essentially the Webpack module federation options. For those of you that are familiar with it, you would see this configuration in your Webpack config. You do need to define a scope as well as the module that we'd like to import. So in this case, we've defined it by that plugin. The plugin is actually responsible for really communicating what this information is. And then the host will go ahead and fetch it and kind of bootstrap it with module federation. So that is the 5,000-foot view of everything that kind of happens with Lattice. It's quite involved, really hard to condense in a brief slideshow, but we're not even close to being done. We've really just scratched the surface here. So some of the items that we also want to address moving forward was the developer experience. So it's really important for us to see how developers are leveraging it and also provide as much information and context as possible when things don't work or when they need to understand, well, how do I add something to a particular area of a page? So we've started doing this with Lattice Dev Tools. It's a very fundamental approach, but it provides some hooks that we would intend to leverage, maybe something as similar to Redux Dev Tools or even the React Debugger or Apollo Dev Tools, stuff like that, where we have globals on the window object that could provide some insight. Another area is improving our testing infrastructure. So right now, there's a lot we can do as far as smoke testing plugins. Again, they're just vanilla JavaScript functions. So we can essentially invoke those methods and do some sanity checks as far as what we're expecting to get back. We're also looking at leveraging tools such as Cypress. So we're using Cypress for testing our UIs today. We would also leverage that moving forward. And there's a lot of ideas we can do there since we're metadata driven. It's very easy to use the same UI, like the same kind of deployment, change the actual configuration that's being used, and run the unit tests again. And we shouldn't see a change, or we should see an intended change that we intended to make different and at least have a test that kind of confirms that. The other thing we're looking at doing is there anything we can do to simplify the remote module process? So far, it works. However, it's something that is a little fragile. So the Webpack federated modules is a little bit cumbersome to understand. However, once it's working, it's beautiful. So maybe there's something we can do to kind of simplify that. Another area we're looking at maybe expanding on is cloud editing. Again, this goes back to since we're metadata driven and we want to kind of reduce any sort of dependencies or compiles, is there things we can do where you're developing these kind of native JavaScript component methods in the cloud and you're able to kind of compile them, which is basically building that bundle and then hosting that bundle somewhere else since it's essentially just static content. And finally, we're looking to just solicit some feedback and iterate on our approach. So that's kind of the high level view as far as what we're doing here. We wrote a blog on Lattice on the Netflix tech blog. So if anybody wants to kind of learn more about it, I encourage you to go check out the Netflix tech blog and you'll see probably some of this presentation, but you'll also maybe see more information that I actually did not cover.
Okay, and now is the room for questions.
Hi, Michael. I've also come from a micro front-end world. I've got a few different things to ask you at once, but let's see how it goes. We had a React application. We called out sub-applications plugins. And one problem we had from when we did breaking changes, we had an internal SDK where very simple information could be exchanged. For example, our plugins or micro applications could get the user's email address. And that was kind of like global information. But when we had breaking changes, we had to do a whole scale of like intermediate SDK changes so it wouldn't break anyone on the fly. For example, have you ever had to do like a React upgrade with potential breaking changes? One thing we thought about later internally, if we had all these micro applications in a monolith repo, it would have been way easier to handle. But we had everything in a separate repo and it was a bit of a pain in the butt. Have you had to do some sort of breaking changes, React upgrades, for example?
Yeah, it's a great question. So far, we're pretty early on in our adoption. However, there's already been a lot of churn. So one of the things that I've kind of noticed is the federated module bundler does a pretty good job at, you know, fetching the actual dependency versions that it needs, and it will actually have its own scope or its own context. One of the problems that we do run into there is shared context. So that may break. However, the one area that we can also kind of lean in on is plugins have the ability to kind of, well, they can re-implement providers, recreate contexts. If there is a disconnect in the API or the data, they can fall back on an old legacy service kind of in their model. So that's kind of the one area that we'd lean in on with breaking changes. We try to make our APIs or our models additive and then kind of flag things for deprecation and track usage over time. We do a decent job at indexing all of our code with source graph. And there's a couple of plugins that can actually see what's going on and what's being used. So that's one area that we can kind of look at. For instance, if we're using these shared declaration files, we'll understand, hey, somebody's on V1 and they should really be on V2. We can kind of single out that project and we'd be able to say, hey, you need to upgrade your type definitions. And as soon as you do that, you would start seeing that, okay, I'm say relying on this email field that doesn't exist anymore. So there are ways to kind of flag or be proactive about searching for dependencies. But when it's disconnected in the federated world, usually what winds up happening is the module bundler will go ahead and fetch a newer version, which could potentially collide. We haven't necessarily ran into that issue, but it's something that I had seen where maybe I'm making things more singleton. And this goes back to kind of our convenience methods that help share information. And if there is an issue, then something has to change either on the Webpack side or on the plugin side, or it has to be upgraded. We are also very resilient to errors. So if a plugin does error out, we always fall back, which is both good and bad because you don't see that there's something wrong. You may be seeing some area of the page where you're like, no, there's no error, everything works. But in reality, something is not being supplied that should be.
Hi. Hi. I was looking myself at the Piral. You probably are familiar with that, right? It's also micro frontend framework, I would say. And they have some kind of, they call it a feed service. It's basically a service where you have all these uh, like submodules registered somehow. Does Lattice have some require something similar, or is this just a static configuration somewhere in the main application?
Yeah, so right now there's no registry, there's no sort of artifactory of plugins. We're not yet at that scale. So right now we're still pretty small in the way we're testing this and the way we're using it. We do see the need of some sort of central repository artifactory based approach, as well as like versioning and stuff like that. At our scale, we wouldn't be interested in any sort of functionality for that just yet. There are other projects going on within Netflix that are leveraging tools like Backstage from Spotify to help with their micro front end approach. And stuff like that, that's where you start needing this centralized repository. But for Lattice, it's more just dynamic applications where you're sharing particular content and there's no real like rigid library to kind of pick from.
Are you planning on adding Lattice to Netflix OSS and to open source it?
Yeah, so that's come up quite a bit. At this stage, it would be pretty premature. So the idea that we would open source it sounds great. It's something we probably will do sometime in the future, but we're also making sure that it's robust enough and that it makes sense. So we're kind of doing our own due diligence, our own kind of sanity checks, dog fooding. And so far, we've already added a bunch of functionality that was lacking in our alpha approach. And we're trying to see exactly, how to make it a lot more robust. The framework itself is super small. It's really just kind of how you use it. And we lean a lot on that freedom and responsibility aspect from application hosts as well as plugins. And that's somewhat unique to Netflix culture. I'm not quite sure it would kind of align well with other organizations. So they kind of like that rigidness or those interfaces to be well defined. So it may happen one day. At this time, probably not.
Okay, so we will leave that to surprise of future. And Michael, one more question. Are there any performance implications by leveraging Lattice?
Yeah, so that's another thing. So since we're focused on internal tooling, we don't necessarily have to have these applications running on, say, mobile. So we're not too worried about payload and bundle sizes. However, we still allow everything that's going on in the Webpack world. So the idea of splitting up chunks, only having the dependencies that are required for that particular plugin, lazy loading, all those sorts of performance benefits are still intact, and really just that Lattice component library or that Lattice framework is extremely small. So it doesn't add really any overhead.
Okay, thank you. And I will have one more. How do you test plugins to ensure they don't break the host application and vice versa?
Yeah, so it's a good question as far as the testing goes. You can certainly do some smoke tests. So we do have some smoke tests that we're looking at. For instance, that vanilla glue with that get component function I called. For instance, if we call it with a bogus identifier that we completely made up, for instance, a random identifier, we're not expecting any changes from the plugin. So it's a quick sanity check where did you kind of make any changes? Did you mutate anything? Did you send in what we sent to you? And if the answer is no, it's like a fast fail. So there are some smoke tests that we're looking at. The ultimate kind of test suite that we're gearing towards is more on the Cypress end. So we would have a host application, it would tie to these external services or those external plugins. And essentially, we would be writing those interactive Cypress tests to click through the UI or do whatever is expected and then assert on the results. So running those automated unit tests in a CI/CD has been pretty slick and works well with Cypress. So we've been leaning on that approach.
Cool. What about server-side rendering and Lattice?
Yeah, so we don't have that particular use case. So we've never tested it, and we'd probably have to implement some sort of caching or fetching model from like if we're using Next.js, we would probably have to implement something like that in place. We've never looked into it. There's some areas of the Netflix that are leveraging Next.js. If we ever did extend Lattice to some of those groups, it would be a use case that we would probably take on.
Okay, cool. Any last questions from the audience? Yes, there is one.
If I understood the presentation correctly, Lattice modules can be just plain old JavaScript things, right? So in theory, I could load whatever framework I wanted to. I could load React again, for example. Is someone loading Vue.js, Angular, and React all at once? Is it possible? And do you look down upon it?
Yeah, so nobody's doing it. They could. It's actually pretty interesting. If you look at the module federation examples, there's a GitHub online. They show all of these. So it's like Vue in React or Angular in React. So technically, it's possible. Somebody could do it. We not necessarily frown upon it, but it doesn't make sense. Perhaps it does. I mean, I have seen some pretty crazy things. I saw a UI that was developed in Scala. So you can kind of go whichever route you want to. It's, yeah, not something we would encourage. Uh, there's a lot of investment on the React side, especially with our design system. So all of those kind of buttons, drop downs, menus, you'll get out of the box with React. So we don't see that, and we don't really intend to see that.